We're now going to look at adding and subtracting polynomials, and the first thing you have to make sure that you do is not get nervous about the word polynomials. If we break the word down into its prefix and root, we get poly and nomial, which simply means many terms. So we're going to be looking at expressions that have many terms. Pretty self-explanatory there. So let's look immediately at something that you already know, a quadratic. And a quadratic is a polynomial. It's one kind. Right? It has three different terms. So the first term is x squared, the second term is 2x, and the third term is 3. Now this quadratic would be a trinomial because it has three terms, just like a tricycle has three wheels, right? And you can't add unlike terms. You can see that these terms are not like. They don't have the same variable or they don't have the same exponent for that one variable. This polynomial at first glance might look like a trinomial, but you can actually simplify because you can put like terms together. This term is an x squared and this term is an x squared, so it has the same variable and the same exponent. 3x squared plus 2x squared is 5x squared. It's just like 3 bananas plus 2 bananas is 5 bananas. Well, 3x squared plus 2x squared is equal to 5x squared. So when we simplify it, we can see that it has two terms. It has an x squared term and it has a constant, and so this would be a binomial. Two terms. If it only has one term, such as 6x, or maybe 3, or 15x squared, we would call it a monomial. And we could debate about whether a monomial could ever be called a polynomial, seeing as though mono means one and poly means many, but really, who's interested in that debate anyways? So as we're going through this chapter, this is going to be one of the most essential things that you remember, is that you can only add and subtract like terms, and they have to be like in order to add and subtract them. We're simply going to apply this thing that we know, right, this phrase, and into adding and subtracting multiple terms. In this case, we're adding one quadratic plus another quadratic. So what we're going to do is we're going to look at which terms are like. Now there's two general ways that I've seen people approach this. The way you proceed to do this, I don't mind. You need to choose which way feels comfortable. So the first way that you might approach this is just looking at this horizontally and matching it up. You might use arcs to match up the like terms. So 2x squared and 4x squared are a like term. We're going to add it. So 2x squared plus 4x squared is 6x squared. You might even cross those out just so you remember that you've already dealt with them. The next one is that you're going to look at 3x and negative 3x. Remember, this is a negative 3x over here because you can always turn into adding the opposite. So we're going to 3x plus negative 3x is 0. So we don't need to write anything down there. We can cross it out so we know we've dealt with it. The last term is going to be negative 3 plus 7, which will be positive 4. So our answer is 6x squared plus 4. Make sure you put it in standard form, which just simply means that the highest exponent down to the lowest exponent. We'll take a look at the exact same problem, but what we'll do is we'll do it the other common method that people do. So the other way people do it is they'll do it vertically and they'll line up common terms. So the x squareds go under each other, the x's go under each other, and then the constants go under each other, and it's an addition problem. So now what we sort of have is a, like a addition problem that you would do vertically. So now as we proceed through the problem, we're just going vertically. 2x squared plus 4x squared is 6x squared. 3x plus negative 3x is 0. And negative 3 plus 7 is 4. Same answer, Just a different way to think about it. Again, I want you to use the method that feels right for you. Here we have a subtraction problem. And like always, as it seems like it is, subtraction just gives us a few more things to think about and remember. I'm going to set this problem up vertically to just show you how you do this one. So as we begin to set it up, right, we can line up the 4x cubes, and I didn't forget the 4. I did left that on purpose. But what we see is that if we try to sort of put in this 2x, it doesn't match up with the 2x squared, right? They're not like terms. So we need to think about where we're going to put that 2x. So where it should go is sort of in this area. So we want the 2x to go here, but it's not going to match up with anything up here. So the 4 needs to leave a space, and we could match up the constant terms. So you're matching up like terms, and when there's not a matching term, it's going to be a blank space. You can leave it blank. You could put in a 0x squared if you want to think about it that way to help you hold the spot. But you need to make sure that they're matching terms. Now we can go ahead and proceed through the subtraction. This is the second part, is that normally when we put the subtraction sign out here, we'll always remember to do the very first one. 5x cubed minus 4x cubed is 1x cubed. And we'll remember to do the second one. 2x squared minus 0x squared is 2x squared. But then by the time we get to the third or fourth term, we sort of forget that it's subtraction. So we might look at this and say, oh, 0x and 2x is 2x, but it's still a subtraction problem. So it's nothing, or 0x minus 2x, which will be a negative 2x. And oftentimes we'll forget by the time we get to the last term, but it's going to be 4 minus a negative 3, not plus. So this will turn into positive 7. We have to make sure that we remember to subtract each one of them. If you want to do it horizontally, the way you might do this is, again, you might find the common terms. So 5x cubed minus 4x cubed is 1x cubed. And then when you get to this one, the 2x squared, you realize it doesn't sort of go in anything over here. So we would want to just leave it alone and just write the 2x squared. And then this is the tricky part, right? There's the 2x over here. You have to remember that there's nothing over here. So it's a 0 minus the 2x. And then 4 minus a negative 3. Tends to be a little trickier with the subtraction when you're doing it in this method. So my suggestion would actually be to sort of ignore the subtraction sign and use what we know always works. We can change that addition sign into adding the opposite. So we can change this into plus a negative. Now, it's a negative whole thing. So we can take that negative and we can sort of distribute it inside everything. So this becomes a negative 4x cubed, this becomes a negative 2x, and this becomes a positive 3. Now we have an addition problem, and that might help people if they prefer addition. I know many of you want an additional surprise, so surprise, there's practice problems. So you know the drill. Give these a shot, stop them. When you're done, come back and we'll see how it goes. Okay, so we'll look at the first one. It is an addition problem. It's really important to make sure you know that before we begin. So we have 4x cubed, and the question is, do we have a common term? And we do, 2x cubed. So 4x cubed plus 2x cubed is 6x cubed. And I'm just going to cross those out so I know they're there. I have a 2x squared. I don't have a common term with 2x squared, so that just simply stays 2x squared. I have 3x plus a positive 4x, that's 7x. I'll cross those out, and last but not least, I have 5. I have to make sure that I'm in standard form, which I am, so I'm good to go. For the second problem, I'll do this vertically for those of you who prefer that. So I'll set it up. It's usually easiest to go in standard form so that everything matches up nice and neat. And I have to remember that this is a subtraction problem. Now we can use the same trick that we did before. So we can either use this as subtraction, or we can change it into adding the opposite. Now if I change this into a plus sign, I'm going to make everything inside of it the opposite. So once I do the opposite of each of the three, now I can add them. Again, that's just a little trick to sort of avoid subtracting altogether. 2x squared plus a negative 4x squared is negative 2x squared. Negative 8x plus a positive 2x is negative 6x. And negative 3 plus a negative 3 is negative 6. A good reminder that if you sort of struggle with those integer operations with positives and negatives, this is a really good time to review those so you know them forward and backwards. Nice job.